Hello everyone, welcome to Analog Patch, it's Astro, and this is the second part of the digital to analog converter vlog on my Musicomputer. And boy do I hope it's the last one of the digital to analog converter parts, because am I tired of fixing them. So as you might see, if you've seen the last episode, this one is way more crowded than it was last time. And it's because I had to desolder all the 22K resistors and replace them with two 10K resistors in series, because apparently an R2R ladder has to be an R2R ladder and not an R2.2R. Otherwise it gives way stranger results, way less contiguous results. But I spent a lot of time fixing them, replacing them, run into a few problems, but eventually made all the four DACs work. This one, which is supposed to mainly be a gate source for these gate outputs, which are not made yet, I didn't fix it. It's still with 22K resistors. It works more or less fine, it just is a bit more ladderish. And it's a backup DAC anyways, so it's mainly for gates, so it doesn't matter that much. These three are working perfectly. But for the one for gates, I made a little extension board, which is pluggable into these pin headers, and it's displaying what's currently on the data bus of it. So as you can see, this is pretty random, and this is because there are random values out there. So yeah, as a demonstration of what I've done, I made a simple multi-wave shape LFO. So here basically I use a sine wave function to generate a sine wave on DAC1 output. Then I divide the sine wave argument by a magic number to get a sawtooth. Then I compare the sine wave to its middle point to get a square wave. And finally, every time the sine wave finishes, I generate a random value for the gate DAC, which is less precise, so I decided to use it for random, because random doesn't have to be contiguous at all. So let's try it. I don't remember which one is which. I think this one is the sine wave one. So this red cable goes to the mixer, just to amplify it, just in case, except it actually it works without it. I've tested it. So it goes to the VCO, and the VCO goes to the output right there. Oh, I didn't guess it. It's actually the random output. So we can see, let's make it a bit louder, that the blinkies change accordingly to the pitch. Let's try another output. Let's try this one. I don't remember which is which. I think this is a square wave. Yeah, this is a square wave. And you can see how it's synchronized also. So they are all synchronized, of course, because they are running off the same argument. This one is a sawtooth. And this one is a sine wave. And on this speed, it sounds really contiguous. It doesn't sound that digital. Although to my ear it still kind of does, but it's not as digital as it could be. But if here we replace this delay value with like something way slower, say 15, and flash it in, you can clearly hear it's a bit ladderish. We can try listening to the sawtooth as well. If you listen very carefully, very closely, you will hear that it has those tiny ladderish bumps in it. It's not very contiguous, unlike analog LFOs. But Yeah, it works. All the 4 digital to analog converters are working perfectly. Well, perfectly to the extent I could make them work, okay? But they still do. And that's great. And I can start integrating keyboard and the screen into this project. Thank you for watching. Catch you next time.